Hello, this is Charlene. We are going to work on a scientific notation problem today. We're going to evaluate this expression right here, and this is actually two expressions. They are being multiplied, so we're going to see how to multiply these. They both are in terms of scientific notation. We note here that we've got 2.4 and we've got times 10 to the fourth. We've got times 5.3 times 10 to the third. So the thing that we want to make sure that we remember is that in scientific notation, you can only have one number in the whole number position. So 2.4, 2 is in the whole number position, and in the 5.3, got 5.3, 5 is in the whole number position. So again, always only have one number that is in the whole number position. These numbers over here are in the decimal position, which is not a whole number. It's a part of a number. So that's the first thing we need to make sure we remember. That scientific notation is only one whole number. So it'll be a number and a decimal, and there will be 1, 2, or 3, just depends on your problem, decimal places after that. Okay, so let's go ahead and erase this stuff so we can kind of look at it. We're going to look at it two different ways. There's actually one way that sometimes students approach it, and they simply take all the numbers times each other. So 2.4 times 10 to the fourth times 5.3 times 10 to the third. And I've actually already completed that on my calculator. And when I did it on my calculator, I multiplied 2.4 times the 10 to the 4 times 5.3 times 10 to the third. And I got this number right here, 127200000. And of course, it looks like this right here. So this is what it looks like when I write it down. And so how would I go about converting that back to scientific notation? Well, I have to remember that the decimal place right now is always at the end of a number. If you are 13 years old, there's actually an invisible decimal point at the end of your number. So the decimal is always hidden a lot of times in just regular numbers. It's at the end of the number. So we're going to have to move this decimal place to the position where there's only one number in the whole number position. So I want my decimal to go right there, 1 point something. So since the invisible one is way over here, I've got to figure out how many decimal places it's going to have to move to get over here to where it needs to be. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So I can rewrite that as 1.272 times 10 to the 8th power. And that's because we moved that decimal place 8 places. So that would be a correct answer for this problem. And you can do it this way if you would like. But I would also like for you to consider the fact that if you have even more decimal places, you would not want to have to write, like, say, 20 zeros. That would be inconvenient if you had lots more zeros. Like if we had 10 to the 20th, we would have had to add 12 more zeros here, 12 more. And that would be a lot of zeros, and that would be very inconvenient. So we want to have an alternative way to think about it as well. So I'm going to go ahead and erase this so we've got some more room to work. And we're going to think about it a second way. Okay, so we are going to think about it in terms of multiplying this part, the 2.4 times the 5.3. Okay, so when I do that first, I actually come up with 2.4 times 5.3 gives me 12.72. So when I just multiply those two things, it's 12.72. So I can put 12.72. Okay, and then I can multiply the 10 to the fourth. Let's change colors there. The 10 to the fourth and the 10 to the third. Well, if you remember how to multiply things that have the same base, like we've got 10 and 10, that's the same base, but they have different exponents. Well, the way I think about it is we've got 4 of them right here, we've got 4 of them right, or 3 of them right there. So that means I have a total of 7 of them. And of course, that means that we actually added 4 plus 3 in order to get the 7. So we could do that. We can say that 10 to the fourth 10 to the 4th right here, and 10 to the 3rd is equal to 10 to the 7th. However, the one problem with this is that we have two numbers in the whole number position, and we need to only have one number in the whole position. So I need to change that, move that decimal place over one place, change it to 1.272. So the thing is, though, is that this means that this is going to change somehow. This is 10 to the 7th now. Well, when I'm going backwards, that number is getting bigger. It's going from 1 to 12, so it's getting bigger going backwards. That means I need another 10 over here to balance it out. I need 1 10 over here. So then my final answer could be 1.272 times 10 to the 8th. So that's the way to think about it in terms of how the numbers are, how the tens are affecting this. If I go backwards from this 1.2 and go back here and get a 12, it's getting bigger as I go backwards. So that means I need to have something bigger over here. I need to have another 10. So I hope that helps you think about it, because like I said, you do not want to always have to be writing, these huge numbers with like 20 zeros on the end of it. So that is the way that I would think about that. And what we did in review is we multiplied the 2.4 times the 5.3, and we got the 12.72. And then we multiplied the 10.4, or 10 to the 4th power, and 10 to the 3rd power, and we got 10 to the 7th power. And then we changed it so that the decimal place was in the correct place. But when we did that, we also had to add another 10 over here because we moved it one place. So we moved it one place, so we needed to add 110 right there. Okay, hopefully that helps you think about it. Just click on the subscribe button. We'll see you back soon.